we're going to multiply. Okay, for number 79, we are given f, g, and h, and we want to find first how to multiply these two functions, f and g. Okay, so let's do it first. Yes, very good. How do you define product of two functions? It is f of x times g of x, right? That is by definition, right? This is by definition. Right? Definition of a product of a function is the product of f of x and g of x. Is that right? Okay. But what is f of x? Write it down. 3x squared minus x minus 10 over x cubed minus 1. What is g? G is x squared plus 5x minus 6 over x squared plus 3x minus, is minus 14? Yeah. And I heard some of you just say, let's factor first. So can you factor the numerator here? How do you factor this? Okay, let's do it on the side. So let me put this on the side. Say this is my scratch paper area. So for 3, it's 3 times 1. How about for negative 10? It's probably 5 and 2. So this is 6. This is 5. So I would need negative 1. So I will have negative 2 here. So you will have negative 6 plus 5, which is negative 1. Right? Okay? So how do you factor this? It will be 3x plus 5 times x minus 2. Okay? How about x cubed minus 1? How do you factor x cubed minus 1? It's x minus 1 times x squared plus x plus 1. Thank you. So good. And then times, how do I factor this? It's x plus 6 times x minus 1. You're awesome. Okay? Is that okay for all of you? Yes. How do you factor that? Can I factor this? Negative 14. How do you factor so that the sum will be 3? No, 7 and 2, the difference is 5, not 3. Am I correct? Okay, so what do you do? Oh, you know what? Actually, I lost a 2 here. Sorry. There's a 2. Okay? So with this 2, let's try. So 2 is 2 and 1. How about negative 14? It could be 7 and 2, right? So now you have 4, you have 7. So let me put a negative sign in front of 2. So you have negative 4 plus 7, that is 3. So you get 2x plus 7 times x minus 2. Is that okay? Now this is good, right? What should I do? Divide out. Okay. You don't say cancel, okay? We will say, because right now it's divide out the common factor, right? Divide out. So you divide out x minus 2, and then x minus 1. Any more? No more, right? So the answer will be 3x plus 5 times x plus 6 over x squared plus x plus 1 times 2x plus 7. Is that okay? Good job. Okay, now, what is the domain? What is a domain? The domain, well, let's see. What is the domain here? You have to come back to the original. This is the original expression. See, for f. Do you see f? This is my f, right? This is my f. Come back to here. For f, remember, the denominator has to be not 0. So x cannot be 1. Do you see that? Do you care about numerator? No. Numerator could be anything. Okay? Okay, now let's look at g. What is the denominator here? Okay, so x cannot be 2. And also x cannot be negative 7 over 2. So now you know, in order for you to be able to talk about f, to be able to talk about g, x cannot be 1, x cannot be 2, x cannot be 7, negative 7 over 2. Am I correct? So in order for you to talk about the product, first you have to be able to talk about f and g, right? So you look back, what is the domain of f, what is the domain of g? All those restrictions you have to include. Is that okay? So what is the domain? So the domain for R, this new function, will be what? All the x values that x cannot be 1, x cannot be 2, x cannot be negative 7 over 2, and x is a real number. Is that okay? So now you say, wow, Dr. Chen, how do I write it in interval notation? Draw a number line. Okay, negative 7 over 2 is here, 1 is here, 2 is here. So cannot be 2, cannot be 1, cannot be negative 7 over 2. So you have here less than negative 7 over 2. You have here between 7 over 2 to 1. And you have here between 1 and 2. And then you have here greater than 2. Do you see that? So in interval notation, what are you going to write? Negative infinity to negative 7 over 2. And then union, negative 7 over 2 to 1. And then union, 1 to 2. And then union, 2 to infinity. Is that okay? We will. In the exam, I will ask you to write in set notation, interval notation, and graph. Yes. Okay? All right, part B. Part B, they want us to find R of x to be the quotient of f of h, f over h, okay, of x. So how do you do? By definition, the quotient of two functions is just the quotient of their values, right? So this is by definition. Okay? F over g, this is a new function. It's f of x over g of x. Okay, right now if you use h, let's use h. Okay, h of x. This is the definition that we learned a long time ago. Okay, now, then what is f? 3x squared minus x minus 10 over x cubed minus 1. What is divided by h? That is multiply 1 over h. Is that right? So you will take what? Reciprocal. So you will multiply x squared minus 1 over 3x squared plus 8x plus 5. Is that okay? And you have factored earlier for f, so you can just use it. 3x plus 5 times x minus 2, x minus 1 times x squared plus x plus 1. All right, now how about for h? So this is x plus 1 times x minus 1. And how about for this? It will be 1 and 3 and 1 and 5, right? So you get x plus 1 times 3x plus 5. Okay? The factoring for this chapter 5 getting pretty straightforward. Okay? This is a trinomial. You just need to factor and make sure that you get it correct. Now, do I see common factor here? Yeah. What do I see? X minus 1, x minus 1. And then 3x plus 5. And divide out with 3x plus 5. And then x plus 1, x plus 1. Any more? No more. So you get x minus 2 over x squared plus x plus 1. Is that okay? So what is the domain? They also ask us the domain, right? So you should not have 1, should not have negative 1, should not have what? Negative 5 over 3, right? So let me put domain here. the domain will be all the x values, the x not equal to 1, x not equal to -1, x not equal to -5/3, and x is a real number. Okay? And now you probably would ask, what about the interval notation? Well, for the interval notation, you probably will draw a number line. -5/3 is here, -1 is here, and 1 is here. So you are going to have 4 parts, right? And then you try to find a union. So you will say it is -infinity to -5/3, union -5/3 to -1, union -1 to 1, and then union 1 to infinity. Is that okay? Okay? I can even write down here. Okay. Thank you, Thomas, for asking that question. It's a wonderful question. I think this concludes the whole section 1. Yeah. This is a very good problem because it involves, let me tell you, this kind of problem will be expected in your chapter exam. Let me tell you why. The factorization involved with difference of cube, difference of square, factor trinomial. Do you see that? Yeah. Okay? And it also asks you, do you know how to divide? Oh, yes, I know. When I divide, I multiply its reciprocal. Okay? So many thanks to Thomas asking this question. And you'd also have to discuss what is the domain, right? In order for you to find the domain, you have to find the domain for each function, right? And you have to look at the denominator. Make sure the denominator not equal to 0. So x cannot be 1, x cannot be -1, x cannot be -5/3. You have to be able to draw on the number line and write it in the interval notation. So now you know what is going to be on the exam. Yes, something like this will be on the exam. Sorry?
Next week is the exam?
Next week,
What
yes.
day?
So,
What day?
Wednesday.
So is that the midterm or this is the exam?
Okay. That is a midterm that combine. I mean, it is focusing on what we're doing, but that I will give you a chance to make up the exam 1. A lot of you hoping that I can, give you some chance to, to bump up your exam 1. Yes, there will be a part additional to this part. I will announce that to you, okay? So there is a time that I will do a midterm review for all of you. It's going to be me, Thursday afternoon, which is tomorrow afternoon, after our class, 4 p.m. I will stay here. I will try to do some review for you guys because I'm going to give you a big quiz on different part of this unit 2, right? Make sure that you get a good preparation. Okay, now let's move on to 5.2. To learn how to add and subtract rational expressions with a common denominator. And then we are going to find the least common denominator of 2 or more rational expressions. If they don't have the common denominator, you do need to find what? Least common denominator. Okay? And then the last, how do you add and subtract rational expressions with the different denominators? Okay, let's look at this. This is piece of cake for you. Why? Because you have the same denominator. When you have the same denominator, you are happy. The common denominator will be just that denominator, right? And then what do? You add the numerator. Do I have all of you with me? So what is the numerator? What is the numerator? 7c. Okay, so x cannot be negative 2. Now, how do you subtract? They have the same denominator, right? So the denominator will be the same, and then you just subtract. Is that right? Okay, so that's piece of cake. How do you add or subtract rational expressions? It goes back to pre-algebra. How do you add or subtract numbers? Okay? Denominator the same, there will be just the same denominator, right? How about if you have different one? Okay? So after you add or subtract, you need to simplify at the end. If you don't have the same denominator, you need to find what? LCD. What does LCD stand for? Least common denominator. So, for example, these two expressions, they have different denominators. So you need to find least common denominator. How? You try to factor the denominator. So factor this denominator is 2 times 3 minus w. The other one is 3 times 3 minus w. So what is LCD? It will be 2 times 3 times 3 minus w. Is that okay? After you find the least common denominator, okay, then you need to then you can add them or subtract them. But how do you find it? How do you find the least common denominator? This is something you learn in pre-algebra, so I'm going to go over the steps again. Can you tell me what you do first? You factor each denominator. Okay? And then when you factor it, you would like to write in exponential form. And then you list all the common factors. If the factors are common except for their power, then list the factor with the highest power. That will be your least common denominator. For example, I'm going to put in one example here. Okay, how do you do least common denominator? Okay, if I have 24 and this is 18, okay? For these two numbers, they don't have the same denominator. What do? You would try to what? Factor 24. What is 24? It's 4 times 6. Okay, or 3 times 8, right? So it's 2 cubed times 3. Am I correct? Minus, what about 19? It's 2 times 9. So it's 2 times 3 squared. Is that right? Okay, now you need to find the LCD. What is LCD now? This is, look, this is 2 to the power 3. This is 2 to the power 1. So for the base 2, you need to use the highest power, which is power what? 3. For the base 3, you need to use the highest power. What is the highest power? 2. This is a way for you to find the LCD. Is that okay? So now LCD is 2 cubed times 3 squared. 2 cubed times 3 squared. Okay? Now, you tell me, what have I done to go from this denominator to that denominator? I multiply by, this is 2 cubed, 2 cubed. This is 3 to the power 1. This is 3 squared. So I have multiplied by 3, right? If I multiply by 3, I need to multiply by 3 in the numerator still. The same, right? Are you with me? No. All right. Rewind. Okay, one more time. How do I do so that I can have the least common denominator? For this, I need to multiply one more 3 to get 3 squared. Am I correct? If I multiply 3 here, I have to multiply 3 there as well. Remember? Yeah. So, you need to multiply 3 over 3. How about here? In order for you to get 2 cubed and 3 squared, you need to multiply what? 2 squared. So you need to multiply 2 squared over 2 squared. Remember? Is that okay? All right? So now you have 2 cubed times 3 squared as the common denominator. And here is 15, and here is 28. Now they have the same denominator, so you can subtract. That is negative 13. Is that okay? All right, so the denominator, you can keep it like this. The major thing is not multiplying out. Okay, the major thing is, can you simplify? Can I simplify, my friend? No, because 13 is prime already, right? There's no common factor here. So you can leave it like this. Okay? Now, let's come back to the rational expression. The same principle. Find the LCD for these two rational expressions. Well, first of all, you try to factor each denominator. Can you follow? Is that okay? For 16, is 2 to the power 4 times x squared times y cubed. Right? For 56, xy to the power 4, what is 56? It's 7 times 8. So 8 is 2 cubed times 7 times x times y to the power 4. So how do you find the LCD? So look at the same base. You choose the highest exponent. So the LCD will be what? Let's talk about it. It will be 2 to the power 4 times 7 to the power 1 times x to the power 2. Oh, 2, right? And then times y to the power 4. You got it. Very good. Awesome. So the LCD is 2 to the power 4 times 7 times x squared times y to the power 4. Is that okay? Which is 16 times 7 times this. All right? Anyway, now, how do we do this? This is a very simple problem. What is LCD right now? XY, right? So what do you do with the second fraction? You have to multiply x over x. Exactly. So you multiply x over x for the second term. So you get 8 over xy plus 9x over xy. And you get 8 plus 9x over xy. Can I simplify? Anybody tell me, can I simplify? No, because what? Because this is addition. This is not a multiplication, right? This is addition. So this is a term, that's a term. It's not a factorization form. So you cannot just divide out this way. They must be in a product form for you to talk about factors. This is not fact. This is a term, right? Are you with me? Now, if you don't have the same denominator, then you have to find the least common denominator and rewrite every expression with the same denominator, and then to add or subtract. And then at the end, you need to simplify. Look at this. What is the common denominator? Well, before you talk about that, you try to factor. Very good. Thank you, Nathan. The LCD is 2 times x minus 3. So for the first term, you need to multiply 2 over 2, right? And you get that. Now, in order for you to subtract, they have the same denominator, and you have this numerator subtract the whole numerator. Okay, I pause here a little bit. I need you to look at it. I mean, I think you don't need to use your paper. You should be able to figure out. Can you tell me how do you do this subtraction? It's 10x plus 12 and then minus x. Okay, I heard somebody say plus, somebody say minus. It's plus or minus. 10x plus 12 over 2x minus 6 minus, this is a bloody mistake. If you cannot overcome this, you probably cannot pass this course because this happens everywhere. Okay? Now you have the same denominator. So 2x minus 6 is your common denominator. How do you do this? It's what? 10x plus 12 minus parentheses. Thank you. That's your C bell, huh? X minus 2. You need this parenthesis because it's subtracting the whole thing. So you will have 10x plus 12 minus x plus 2. Is that okay? And you need to simplify, become 9x plus 14. So you will have 9x plus 14 over 2x minus 6. Is that okay? All right. See? For this section, it's short. You need to get that concept. But you need to practice as well, right? Can I have you look at 5.2, everybody? Look at 5.2. Okay, open your book to page 430. Yeah. Okay. Start doing, because your homework, you have textbook homework. I'm going to put that on the board. And I want you to start doing those homework. Okay? #21 is a problem that you have to get used to. What is the opposite? Okay, number 21. What is 21? It's 3x over x minus 5 plus 1 over 5 minus x. Can you tell me what is the, do they have the same denominator? No, but what is the LCD? Oh, you multiply them? Very good, very good. I heard people say, multiply them. The other people say, oh, actually they are opposite, right? Note, x minus 5, okay, is negative of 5 minus x. Is that okay? Yeah. Or you can say 5 minus x is the opposite of x minus 5. Do you know what I'm saying? So when you see this, you say, oh, I can rewrite it. I can write this as negative x minus 5. Are you with me? So what is LCD? It's just x minus 5. And then you will say that is the negative can go up. Why? Okay, 3 over negative 5 is negative 3 over 5 or negative 3 over 5. The negative sign can go either in the denominator or the numerator or outside, right? Right. You multiply this by negative 1. What do you mean by this? This is negative 1 times. Negative x minus 5 is negative 1 times x minus 5. Okay? So now you get what? 3x minus 1 over x minus 5. Is that okay? Good job. Okay. I'm going to... yes, I can leave it here. If you know this section 2, then section 3 will be piece of cake. Piece of cake. Section 3. Okay. Are you all done with this? Yes. Okay, so this is very simple, but it's so important, okay? This is very important. I already do one problem. You only have 5 more when you go home with the My Math Lab, okay? And then you will do the pre-reading. You are going to do the pre-reading again. Yeah, I'm going to have you do the 6.1 and 6.2. Okay, now 5 point, okay, can I start this? So I know, yeah, 5.3. It's just a starting. Let you know what's going on with complex, because this is actually the tail of 5.2. Complex rational expressions. So the only thing is different is what? You have a complex in front of rational expressions. Why we say it is complex? It is because it is a fraction inside a fraction. Okay? Right. Okay, so what would be like that? Let me give you one example. Okay? Let me give you one example. Simplify 2x over x plus 4 minus x minus 7 over x squared minus 16. Do you know this, my friend? Yes. How many of you raise your hand if you say, I know how to simplify this? Of course, right? Yeah, we just did this. All right, but in order to make it complex, look what I'm going to do, okay? I'm going to do a magic. I'm going to do a magic. I make it as my numerator, and then I put this. All right, so look at that. Do you like that? Yes, you say, I know that. Look at that. Do you know that? You say, yes, I know that. But I just do a what? Division. Do you see that? Yes or no?
I don't know nothing.
You don't know nothing? Okay. No. I'm just saying that in this section 5.3, we are doing this. Means what? This divide by that. Is that clear? Okay, this is a question. All right, then how do I do? How do I do? How do I do? And you say, well, Dr. Chen, we just learned. We just learned. I know how to do this, right? And I know how to do that. So is this divided by that? Am I correct? Yes or no? Yes, right? So I will try to just write it in a way that looks friendly. This divided by that. Do I make it friendly to you now? Yes or no? This long line it means what? Divide. Right? So it's a giant. And then just say, okay, it's this numerator divided by the denominator. Does it make sense now? Okay, I'm going to pause here. And I want to ask you, does it make sense to all of you? You mean this problem? This is a problem. This is a problem. I put it on. This is a problem. And I want you to simplify. The whole idea is to simplify the whole thing. So don't get scared by looking at this. Well, I know it looks like a giant monster, huh? Because you try to dissect it. You say, hey, what is a numerator? This is my numerator. Hey, what is my denominator? This is my denominator. So it's a numerator divided by denominator. Is it okay? All right, now let's look at part of it. Can you do this? Can you do that? Can you change the division to its multiplication? Yes. So let's do it, okay? So let's say, what is this? This is 2x over x plus 4 minus, what is this? This is x plus 4 times x minus 4 in the denominator. Are you with me? Now, okay, let me still keep this division. Now, how about this? This is x over 1. Are you with me? Do you agree that's x over 1? Yes. So, what is LCD for this problem? It's x minus 4. So, I'm going to say, x plus 4. So, I'm going to multiply x plus 4 over x plus 4. Do you know what I'm doing? Okay? So I will have x times x plus 4 over x plus 4 minus x squared plus 4 over x plus 4. Now they have the same denominator, right? Okay. All right. What is LCD here? You have to multiply what? X minus 4. So x minus 4 over x minus 4. Is that okay? Yes or no? Okay, so for this, x plus 4 times x minus 4 will be your common denominator. How about the numerator? It's 2x times x minus 4 minus, Thomas, I like your parentheses. Okay? It's a parentheses of what? X minus 7. Yes? Okay? I still keep my division sign. That's okay. Now here, this is, the denominator is x minus plus 4, right? How about the numerator? This is x times x plus 4 minus, remember, Thomas, oh, have to remember, Thomas, when you do subtraction, okay? Thomas, say, put parentheses. Okay? Okay. So far, so good? It's really complex, isn't it? All right. So now what do you have? You have 2, you try to distribute it. 2x squared minus 8x, and then what? Minus x, and then plus 7. And here is x plus 4, x minus 4. Still divide. This is x plus 4, and here you have what? X squared plus 4x minus x squared minus 4. Are you with me? Okay, so let me move up. Simplify it. So you get 2x squared minus 9x plus 7. Are you with me? You have x plus 4 over x minus 4. And you have, can I change it to multiplication now? Okay, so I'm going to take, it's a reciprocal. So I have x plus 4 here. And how about here? This is subtract off, right? So 4x minus 4. Can I factor out 4? So become 4 times x minus 1. Is that okay? Am I too fast for you guys? Yeah. Okay. Right. Rewind, rewind, rewind. From here to here, I just write as a numerator divided by denominator, right? From here to here, what did I do? Find the LCD, right? From here to here, what did I do? I just tried to subtract the numerator, right? Okay? From here to here, I just simplify, right? Okay? I'm simplifying. Is that okay? All right. Now, I would like to multiply. But before I multiply, I like to factor. Can I factor that guy? Yes. 2 and 1. 7 and 1. Negative 7, negative 1. So I get 2x minus 7 times x minus 1 over x plus 4, x minus 4, times 4 times x minus 1 in the denominator, and then x plus 4 in the numerator. Is that okay?
How come you never taught us how to do that one?
On the left?
The scratch word. The scratch word. You never taught us how to do that.
This one?
You never taught us how to do that. I don't know how you do that.
Oh, okay. You don't need to do this if you would like to just using the grouping.
But it looks easier, that's why, and I don't know how to do it.
I see. So the substitute did not show you this way. Ah, okay. You know what? What I do is I'm trying to, look at this. This is exactly the vertical way of this. See, this is horizontal, right? 2x minus 7 times x minus 1. I am putting x minus 1 under it. I just did not put x here. Oh, yes, that's right. Oh, we are too engaged. Okay, thank you. All right, we are going to end this here. I'm going to upload this on Canvas, okay? We'll see you tomorrow. Prepare your quiz. Thank you.